just one thing, Adrian. Where are you? There you are. We are, by this time next year, we will have halved the number of 20C exchanges. Nice. 850 new nodes are being rolled out. A wholesaler probably only announced them in 100 blocks because they like to do that, but that's by the by. So I wanted to talk about a new service that we're going to launch that Adrian can complain about. In fact, I've just remembered one thing. Sorry. So, G.Fast and NGA2. So, G.Fast is a new DSL technology, originally called Omega DSL, because the view was it would be the last probably DSL equivalent, but actually it's not. It's looking like it won't be, which is quite interesting. But in effect, so we announced this our results on 30th of January. And what we're looking at, and we've put 10-year vision on it because there's some big challenges we need to overcome, and actually the build's pretty significant, but I suspect it won't take us 10 years. And also, one of the things I've personally been frustrated about in BT is actually the fact of people who want to fibre to the prem, it's very difficult to get it. So it's something I've personally been involved in fixing. And we've still got a way to go, but I think over the next couple of years, that's definitely going to get better. So, this is kind of a simple picture of our network. We have an exchange, we have a PCP, we have a FTTC cabinet. We also, unbeknownst to most, have a load of other points, distribution points, where you might see a box on the wall or on a pole, and that kind of, or underground actually. Or actually in the basement of your block of flats on occasions. And we've been, G.Fast, we've been, you know, we got just about 20 million homes on FTTC, and by the end of 2017 we'll get about 95% of, you know, up to 80 meg, but clearly there's still more work to do. So we've been working with the big vendors and other telcos on G.Fast, and G.Fast was originally a technology that you would stick on a pole very near the premise. So if you think about it, you'd have to build it to kind of 4 million locations, which is a pretty big build project. Given cabinets, there's about 90,000 of which I think we'll probably use, I think it's roughly about 50,000 for FTTC. That number might not be right though, I can't remember off the top of my head. But you kind of see the speed going from kind of 64K in the 60s right up to, with the right line length on G.Fast, actually 1 gig. We actually think it will go beyond that, but we don't want to risk it in case we get an evil letter from Adrian. The good news is G.Fast is a technology where we can use what we call forward powering, and we actually have this working right now where we can power a G.Fast box from our VDSL node. The biggest part of the build in NGA is the power. Actually, our bit's relatively straightforward, but every time you deploy a cabinet, the Lecky board's got to deploy a power feed and a meter. So we built a new lab up at Adastral Park that kind of simulates a street, wide range of open-reach cables, how they perform, and we've been doing a lot of work with both the silicon manufacturers, so Scipio, Broadcom, and some others, and also with the kind of 3 main DSL suppliers, Alcatel, Lucent, Adtran, and Huawei. We also have a big CPE and DP kind of room where there's lots of kind of, you know, home users pretending to be on broadband. Again, this just covers some of the detail of it, and the bit between the fibre part and the handover parts simplified. But in effect, you've got your PCP, which is the cabinet usually that someone's spray painted on, and then this new DSLAM cabinet that's usually buzzing, and then potentially we put either G.Fast box in that cabinet existing, or put one close to it wherever if there's a challenge on space. And some of our early cabinets, they are space challenged. You then end up with a G.Fast coverage area, and in some parts still VDSL2, but you'll be able to offer both services. And then further down the road, you might have a G.Fast box, and these are kind of rugged enclosure box. I was trying to bring one here, but I was just worried. I had to fly. I was just worried that it just wouldn't make it with me if I flew. So I didn't risk it. No, it is very rugged, but I just imagine what the guys scratching their head at security. What the hell's that? As it goes through the X-ray machine. And then, but in effect, deploy this further down this into the streets or even into the bottom of buildings. Kind of how we do FTTRN right now, which is kind of fibre to the remote node, and then again be able to serve other houses G.Fast. So we're going to run actually three pilots this summer. Huntingdon in Cambridgeshire, Gosforth in some place called Newcastle upon Tyne, and Swansea. And we're doing about 2,000 premises. And it will be kind of the first big deployment of G.Fast in the UK. And if you're already an OpenReach customer and buy from them, you'll be able to take part in the trial. And actually, this is an earlier technical trial that we had, and I just wanted to cover this in a little bit of detail. G.Fast is going through a number of different standards. The first, there's kind of a pre-G.Fast standard, and then there's now the standard that was ratified recently, but there's also some additions that we're working on. In this location, which I forget where it is, I'll get my notes in a sec, but we, header set, sorry, and this is using Alcatel equipment. In this location, and I'm going to have to kind of point a little bit here, but we were able to, at a 200-metre range, we had customers getting 350 megs worth of bandwidth speed. We had one customer who was at 50 metres who was getting north of 500 meg. And this is with the kind of pre-release, pre-standard equipment. And actually we think with the current work that we've got going on around the G.Fast standard, we think we can actually push that so that, you know, roughly, and if you think the average loop length from a cabinet might be, you know, 200 to 300 metres, we believe we could easily get 500 meg to a lot of premises. To do that, we need higher bits per tone. We need to reduce the noise floor. So, I mean, the reason that we're able to do this is the quality of receivers it's just a world better than what it used to be. So actually, when you look at the technology and you pull a receiver apart, there's not a lot of difference in them. But what's improved is the actual quality and the manufacturing of them. Increase the transmit power, and then optimize the frequency usage with VDSL. So clearly, in the ANFP, there's a set amount of bands that we can use and some that we can't. And VDSL is not well optimized, or not as optimized as it could be. And that, again, that would release more bandwidth for G.Fast. And then also with FTTC and VDSL2 in general, but also G.Fast, vectoring becomes more important because you get, especially at G.Fast, because you're using a wider set of frequencies, you get a much wider set of crosstalk and noise challenges. So, you know, you kind of need bigger digital signal processors, a much bigger engine to do vectoring to drive it up. But basically, without vectoring, there is no G.Fast. And you know, we're OpenReach are trialling vectoring in some locations to boost speeds and also reduce noise overall. And we're working with the EU on this, and our research teams are plugged into the EU via, and we've also got kind of working very closely with Deutsche Telekom, some of the US telcos that do DSL to try to really drive forward, you know, much more on G.Fast. But I mentioned fibre earlier on, so we're actually doing a number of trials right now. BT's approach to fibre is historically splice, which is great from a noise and kind of quality point of view, but it's really bad from a deployment and length of deployment point of view. So, you know, to do an FTTP or a FOD, just to do the splicing in your house, it can take almost a whole day. Connectorization is effectively pre-made lengths of cable, pre-made kind of chambers that we put either at the top of poles or in the ground, so that it's easy for an engineer just to clamp onto them. Also means you can test easier with some of the other technology that we have. So today we do a lot of fibre that you blow through a hole, and the challenge with that is you've got a compressor set up, you've got a huge amount of kit that you need to carry with you, and also 9 times out of 10 there's a blockage. And the minute we hit a blockage, it's kind of men with big diggers to fix it. So what are we doing about that? There's a new kind of drop cable that's been used in other fields that Corning have just done, SST, which is, I can't remember what it stands for. It's some, in effect, it's self deploying in the respect that the cable, rather than having multiple fibres in it, it's got a few less fibres, but it's got a very thick core, so it will actually self-clear some of the smaller blockages in a duct. Therefore, you know, there's a good chance that you'll get much more deployment without having to do heavy digs. The other thing is you know, anyone who's worked with fibre, trying to peel the fibre to do a splice is a nightmare. Again, Corning and other guys have got some great fibre where you can literally peel it apart to get to the fibre. And that allows us to do much less kind of splicing in the garden or kind of bolting things onto walls and stuff like that. We can actually get it much more neater into the house, and also we can do an end-to-end test from the presentation point all the way back to a port. We're piloting this in Thornton Heath. I think we've got about 20 homes live on this trial, which we started, I think, only a couple of months ago. We're going to do some other trials, but we're really kind of driving to be able to do fibre on demand in a way that actually works. The current way that we've got, as we can see, just isn't. Whilst we can make it work, it's just not the best for a simple install. So to sum up, we're doing G.Fast. We'll get 500 meg, and you know, within the next 5 years, we're doing some trials. We're really working with industry. All those CPs that are customers of OpenReach, I really encourage you to get part of the trial and get engaged. There's a bunch of other architectural issues in the rest of BT's network. So how do you cope with thousands of users that have got 500 meg? And you know, what's the backhaul technology you need there? Also, we want to bin PPP because it's rubbish and it doesn't scale. So we want to do IPOE, and in reality, we probably should have done this when we did FTDC, but for compatibility reasons, it was just easier not to do it then. But doing PPP for this sort of speed, whilst it's possible, it's just not valuable. So it's likely that the delivery mechanism for this will be IPOE, which then brings into another set of issues because it's self-adapting, which means you don't know what speed you're going to get when you talk to the BRAS. So how do you manage speeds and policies? Quite difficult. So there's a bunch of other architectural issues that we've got to figure out. But we're very happy to be offering service providers more products to sell. Any questions? James.
James Blessing, Keycom. Quick question. That looked like a third cabinet in the street.
Yep.
How are the councils going to go down with that one? Because they don't like two.
Well, they don't have to have it. I mean, you know, do you want fast broadband in a rich economy where you can charge more for council tax, Mr. Councillor, so? You know, but I suspect, I mean, it's there as illustrative. I suspect for most of the locations we won't need 3 cabinets, but you know, we'll also probably need to build. I mean, the cabinet infrastructure, if you look at it, it's kind of designed in the 50s, and all the house building that's happened since, we haven't really built the same architecture as what was built back then. So I suspect we'll see a lot of new cabinets, but not kind of 3 at a time. But you know, it's a choice. You don't have to have it, as Kensington and Chelsea found out. Who's next? Which one?
Hi.
Adva man, sorry, I forget your name.
Hi Neil, it's Anthony McGee from Adva Optical Networking.
That's it.
We're seeing a lot of people in mainland Europe, service providers in mainland Europe looking at convergence. And when I mean convergence, structural convergence of the network to support fixed and mobile. Do you think G.Fast is a technology that will enable mobile backhaul and fronthaul services? And are you looking at wavelength routed services as a partner with G.Fast?
Yeah, I mean, I think both of them will be useful technology. So one of the advantages G.Fast has, it syncs almost immediately. So the minute you turn it on, it syncs right away. Because one of the big issues, if you're deploying TV and your router reboots, you know, it can take 5 minutes for it to resync. So on that basis, where you got mobile synchronization, if you do have a problem, it can come back up very quickly. Will it be suitable for every location? Probably not. But will it be suitable for none? I think actually, as we push the bandwidth boundaries and we push the coverage boundaries, I think what's going to be true is there will be a mixed economy of different options, because not all options are going to be affordable or even reasonable to do, even if you had the money. So, you know, everyone says, oh, why don't you just roll out fibre to everywhere? Let me just go back to this slide. So rolling out fibre to 29 million locations, even if I had all the money in the world, there aren't enough people to do it. And we're already bussing people in from Eastern Europe to do our current build. So, it's money's a challenge, but the resourcing to do it is an even bigger challenge. There's another question at the back.
One here first.
Oh, sorry, one here first, apparently.
At the front.
Hello.
Yeah.
Hi, it's Robin from TMP.
Hello, Robin.
Hi. How much of a challenge do you think it is keeping the backhauls to the cabinets? I think a lot of backhauls are shared PON-style backhauls at the moment. How much of a challenge is it getting those up to spec for this kind of bandwidth? Because as an LLU operator at the moment, the sort of stats to these cabinets, the backhauls to the cabinets, isn't something we have any visibility of, so it's difficult to know how used the backhauls to the cabinets are at the moment.
Yeah, no, that's a good question. I mean, clearly if you're doing 500 meg and you've got a 2.5 gig GPON, you're going to run into some challenges. Fortunately for us, when we built it, we deployed filters, so I can add XGPON whenever I feel like it. XGPON will be available probably in early versions later this year. We've done some trials with it with Huawei. So in fact, we can do TDM-based WDM and run on each PON north of, I don't know, what would be 40 times 10 gig, that sort of number.
Okay,
is that enough?
Table in front.
Hi Neil, it's Dave Wilson from WarwickNet.
Hi Dave.
Is your long-term plan that you're going to try and get this stuff everywhere?
Which stuff is that?
Well, the G.Fast, the vectoring especially.
Where are you, Dave? Wave at me. Sorry. Oh, there you are. Sorry.
Only little.
I think the goal is to connect as many people as we can, and we want to drive out to as many locations and serve as many people and customers as we possibly can. Okay.
Do you have a plan for what you do when you turn up to a PCP that's already got another vectoring DSLAM hooked into it?
No, but that will be an interesting challenge, because if there's someone else doing vectoring, then the show's over, especially for G.Fast.
We've already got 30 of them in the field.
Yeah, so that 30 location, you know, that might be yours forever. So I hope you're rolling out G.Fast.
Okay, and then Adrian, and then at the back.
Sorry, yeah, he's been here a while.
Yeah, Adrian Manders-Arnold, obviously. Not having a go, honest. This is actually quite encouraging, and am I right to understand that all of this and the FTTC we have now is essentially something that, oh you sod, essentially something, I'm going to put my jacket on, it's essentially something that is an open reach data service and should hopefully have some very clearly defined metrics for what is and is not a fault, so that we don't have all of this stupidity in the future with SFI, where someone in the middle is buying a copper path from OpenReach and that's all you prove.
Yeah, so I mean, I think OpenReach have been working with some CPs to kind of define a broadband line standard, but it sounds really easy. Actually, it's very difficult. Remember, this stuff was originally invented to do 64K phone lines over long distances. So actually, it would you know, if I think about it from any service provider point of view, your goal is to have a very tightly, well-defined kind of service policy. right? Not just for the customer, but for you and vice versa, so you can know what the performance of it is. Sometimes that's a lot harder to do. So what do we do? Do we not offer the product, or do we offer the product and have maybe one or two variables around it? I think often the product's probably the better answer. Sorry, this gentleman here.
Hi, George from Australia, as it happens, and as you
George
know,
from Australia.
Yeah, as you know,
you'll know about successful deployments then.
Well, as you know, the news of what you guys have been doing had a massive effect on our political economy of broadband. I'd really encourage you to publish your experiences with drop-off on the data rate, because that's one of the top issues that people are asking. What can actually be achieved in the field?
Yeah, so in the field we go, it all depends on your average copper line length. Ours is around between 200 and 300 meters, so we're going to be able to do, we're pretty confident we'll be able to do 500 meg. But it requires new silicon, it requires some effort in the standards. The other challenge we've got is there's a VDSL kind of 2+ standard that basically breaks loads of the spectrum, so we have to kind of encourage people not to go down that route. There's a lot of challenges in getting this out, but we think it's the next best investment.
The other big issue for us is the contestability to the DSLAM, but you already said if someone else is vectoring, then game over, Red Rover. Yeah, I mean
that is a big issue, and it's something that we need to face into, because the WarNet guys have done unbundling. There's a few other CPs that have done it as well. Any other questions? One down here.
Hello.
Sorry, one over there.
Hi, sorry to hog the mic. Robin from TMP. Just one other question. You're talking about the vectoring just now. I had read in a few places that it was possible if you could sync up the two DSLAMs together with two operators, that they could then sort of organise the vectoring between them. Is that something that you've looked into, or do you think it's possible?
It's not the architecture most vendors are going with, so probably not. I mean, so we're working with Huawei, ECI, Alcatel-Lucent, and none of them are offering that sort of solution. Certainly not in a way that they are proposing that we deploy it.
Okay.
Feels challenging.
Last question here.
Hello.
Hi, it's Rich from X Networks.
Hi, Rich.
How do you intend to wholesale IPOE, removing PPP from the mix? Is it sort of a VPLS instance which covers all our customers delivered over?
Yeah, I mean, so this is kind of a slide on the list of issues we need to solve, and it will be something like that, or potentially through VLANs, although I personally would like to try and avoid that, especially 500 meg VLANs, but it would be something like that, and we are, OpenReach and BT Wholesale, we're committed to sharing our network, unlike others, so we will make it a way that's shareable for you, but also it's shareable and you can consume it in a cost-effective way.
Thanks.
Are we done?
Okay, thank you very much, Neil.
You're welcome.